Welcome to the session on a self-evaluation framework to develop an AI strategy for your company by Mike Grant. I am Anton Grutter from the Lean Institute Africa. Just a brief word about Mike. He has a PhD in electrical engineering and has received several awards for his work. Has a wealth of experience in creating and commercializing highly successful AI-powered products, mostly in the role of Chief Technology Officer, and he's currently with Synthesis Software Labs. So Mike likes diving into complex problems, engineering industrial systems, developing teams, and sharing his considerable insight into this very topical issue of AI. Can I ask that participants ask questions even early during Mike's presentation, but only in the Q&A so that we can pick them up at the end of his presentation. Over to you, Mike.
Thanks, Anton. It's really exciting to be chatting to you all today, and greetings from sunny Cape Town. I'm really excited to be sort of sharing this specific view because a lot of the conversations I get to have with folk around the world is around bringing AI to life. There's a hell of a lot of attention for this technology in the media. There's some incredibly vibrant use cases that are shown there, and often we find ourselves looking up at these aspirational implementations and asking ourselves, what's the transformation journey I've got to go through to get there? Where do I start? What are the right set of tools that we need to add in and build so that we can make the correct start, so that we can add the right kind of value to the business? So what I have done together with my team is we've compiled this disruption framework. And the whole idea behind this is to guide your thinking through these 6 dimensions. And these 6 dimensions allow you to take your specific problem. And the challenge with any sort of like industrial operation is that it's unique. The way you do it is entirely different to the way that anybody else may ever try and do it. And I think that it's really important to sort of understand that. And it's really important to say, well, how do I get started in the right place, add value, and then we can sort of grow on from that. Like, what is the strategy? So we've got these 6 dimensions. We speak to a problem, we speak to an interface, we speak to the specific technology, we speak to the operations and the role that people play in those operations. And then we talk about an external source of disruption. And generally speaking, you can imagine yourself sitting on a spectrum, somewhere on a spectrum, between being replaced by AI, because I think it's very important that we talk openly about the fact that many folk are up for replacement, through to the protection, where you have a protection stance, where you try and potentially prevent the loss of your value contribution through to AI systems. And finally, in an acceptance domain, where you are able to say, well, I wholly accept this stuff, and I'm going to change the way in which I interact with the world, and I'm going to use AI to drive that change. Importantly here, we have disruptors who drive acceptance. We have this moving middle, which is the shifting target as technology evolves, and then we have the disrupted. So we're going to be left behind. So I'm mindful that we don't have a hell of a lot of time, so I'm going to jump straight on into it. And so if I can ask that, as maybe if a question comes through appropriate to a specific dimension, just interrupt me and we can unpack the detail a bit further, because I think it could be helpful just to do it then and there as it comes through. So I'm going to talk a little bit about the problem. The problem is really the task at hand. When we look at the world, we sort of see a spectrum of things. When we look at it, we also have people who can deal with these different things. So we talk about a well-defined task, which is a super simple action. It's very much point in time. You know, like what the precise boundary around that task is. So you know what good looks like, you know what the success criteria is, you know what tools you need. And if you look at the task in its whole, it's really not open for transformation there, right? We can evolve this into becoming a little bit more complex, which is tasks that have multiple steps. So it's a task, but within the task, you have a few steps, but there's still clear instructions around the sequence of actions you need to take, and there's no absence of definition. Task complexity can keep evolving, so we can have complex tasks. These can be sort of clearly defined objectives with well-defined constraints, but it's not as perfectly constrained or boxed as a well-defined task is. We can evolve from tasks to objectives. So an objective is something that's sort of stated need, and we have a series of tasks to achieve this objective. But it's well defined, right? So you can say, this is my objective, and to get there, I have these derivative tasks that help me get there. Then we have tasks with interdependent steps. So there's some ambiguous constraints, but you've got to take the output from one task. You've got to think and apply your mind and get to the output of another task. So it's like a complex string of tasks that might be constrained in a non-obvious way. So only when you actually grapple with the movement of things between different steps in the task that you understand it. We can evolve that to a complex problem. Here, there could in fact be multiple solutions. So you have to sort of choose between which one. So you come up in the solution mode, you say, this will work, and that will work. And so you have to then critically evaluate the solutions that are presented and choose the best one across something that is generally not very well understood. And lastly, the sort of ill-defined problem, typically your engineers or your business leaders are tackling with this. It's kind of like build a bridge, or I want to get to the other side of the river. One of the solutions is build a bridge. But it's sort of a broadly described problem, and even the constraints may not be immediately obvious. Excellent. Anton, do we have any queries on this?
Not yet.
Awesome. Okay, so moving on to the next dimension of this disruption framework, speaking to the interface. Now, the interface is really how you interact with the thing or the problem aspects of the task or objective or ill-defined problem, right? So you could have a very mature system where there's an existing automation interface. It's very easy to interact with it. You know, you can issue an instruction and whatever it is. So typically, like in a computer, it's very easy because there's an automation interface, and you can describe the transformation you need to go through to resolve these things. You don't really require any sort of involvement past telling the interface what you want, and it just happens as per magic. The next sort of evolution in that is an API, also again a digital interface. But this digital interface has very well-defined parameters. It has a way of interacting. It has an expected return. It's very sensible, very well-controlled, a sort of way of interacting. The system complexity behind it could be a little bit more complex. So you could in fact have failure modes, or you may have to make several queries to the API to accomplish your task. The next evolution up, again in the digital space, is a way of interacting with some technology, but without a very well-defined interface. So typically you have like a graphical user interface, and you've got to use these analog interfaces, like moving a mouse, or touching a screen, or typing something with a keyboard to interact with it. So the interface has been designed for people, but you are now trying to automate the role, or trying to interact with this in a non-human way, right? So now you've got to think about, like, what is on the screen? What are the components that are there? How do I choose the right one? Then you get the next sort of evolution is some kind of proprietary interface. So it's an uncommon interface for some well-defined system or physical problem, but the physical problem can be manipulated with some kind of actuators. And here I think about like a sort of like operator sitting in front of a row of machines who has a bunch of knobs and stuff that he's got to go and press or and twiddle to get the necessary output. So it's bespoke. It's only one of these exists, and you've got to think of a way in which you can actually sort of like interact with that system, right? So the way in which you get there is hard. Because this is uncommon, and so then actually like building the integration to this uncommon interface is where the challenge lies, where the sort of problem space sits, right? So I think that that is the important part there. The next sort of evolution in complexity, and again, what we're doing is we're moving in sort of like from the easy to disrupt to the disruptors. It's hard to change, but if you've mastered this, you can then drive the change agenda. Is where you then have a combination of interfaces. So maybe I've got to go and get some data, and then I've got to go and set a machine value, and then I've got to go and take the output of that and apply it to some kind of financial model or so. So you've got to like to apply some sort of context in the mind of the person who's solving the problem and evolve it between these different spaces. And then we've got like the really hairy stuff. It's very hard to do, like voice recognition. So, hey Siri, do something is quite an easy thing to achieve, but actually getting the right output without any error is incredibly difficult. So these sort of like interactive physical interfaces that are ill-defined are hard to with. And then in fact, it turns out that the hardest thing is an undefined physical interface, like plastic injection molding, if you would, right? Like you've kind of a complicated sort of thing that you've got to get right and get the component made, and you've got a variety of parameters and there's process optimizations. But this isn't that. This is the actual physics of the problem that I'm referring to. Good. Okay, so that speaks to the interface. Now, there's another aspect. It's kind of similar to the interface, but it's the actual technology. And here I'm sort of speaking to the fact that you've got to have the right technology matched to the right problem. So it sort of speaks to the solution space to problem space fit between these things. And this is really about using the right tool for the job, right? It's hammers for nails and spoons for soup. It's the right thing at the right time. And here, in fact, if you have human manipulation, right, you go and pick up the right tool and you smack a hammer onto a nail and the nail goes into the wood. It's very easy to do, right? The next level of complexity of technology is where you have these basic digital tools. So here you have a tool or a tool chain coming out of software like Excel connecting to a database and plotting some pictures, some graphs for you. The next evolution in technology sophistication is cloud-based platforms. So here there are ways in which the data can be shared between participants, manipulated by multiple actors in a system. The next evolution on that is where we start tying these systems together, be it cloud or even be it on the floor of an operation. You've got these interesting things. And so you've got these different modes of operations between these different systems, and you've got to think about how that technology spans these different modes of interaction. And the next evolution, because they're all around us, is actually where we are using AI tools for process optimization already. Right? So like if you think about a banking system, there's a series of transactions, and there's a more efficient way to work through that series of transactions. And so you can optimize it. So now you're dealing with a self-optimizing system from an external interface. And so that's quite a complex piece of technology where the behavior isn't very well understood without sort of unpacking the inherent dynamics in it. Then you've got these like much more complex integrated smart systems. So you can think about a whole bunch of AI traders on a stock exchange, for example. And so here you have this optimizing or self-optimizing technology at multiple points in the system, all interacting in a much larger, broader system context, which is quite interesting because you can't really optimize for these sort of emergent dynamics because they're very hard to express. And finally, the most sort of highest calling of technology, if you would, is how it is used to create systems, because there are a bunch of folk who can actually go and make these things, make new ways of interacting with these technologies that enable that. And so when you deal with that technology, it's sort of at a much more abstract level. It's very hard to connect that to a problem space, but you are sort of involving the world in a new way. Okay, very exciting. We're sort of moving on to the operations of or the role that people play in an operation. So we're talking about like what is the value that a person brings when they check in the morning, right? So at the simplest level, you've got a process, can be anything, can be a bank teller, can be a physical machine operator that would, and they are there as the process drivers. Their sole existence is predicated on the fact that the interface that they deal with is too complicated for an unskilled person to resolve, or an unskilled person doesn't want to do it. And so you have to have this person who drives the process forward. It could in fact be a menial task, as simple as sort of adding a screw cap or a lid to a bottle. But that contribution of the person is as the driver of the process. The next evolution is where people become supervisors. So we have, just using the same example, maybe a pick and place machine that screws the cap onto a bottle, but the person stands back. Their hands aren't necessarily directly connected to the output, but they're just sort of watching the process. They're monitoring this process through the outputs, through observation. The next evolution is where people stand even further back from the process and they look at the output of the process and they say, is it good enough? Does it meet my requirements? Which is an interesting point to do, is you have this thing that's happening, all this sort of exciting stuff, but the sort of person then says, well, is the system really doing what I want it to do, and makes adjustments if necessary. Then you have process optimizers. And these folk will look at a process and say, well, maybe I can get it to run a bit quicker if I made this subtle change. I change the order of something. Maybe I pre-fill the bottle, or maybe I replace the bottom gripper with a turner so that the screwing of the cap onto the bottle takes fewer seconds. Something like that, right? Where the person takes not a view on output, but a view on rate and throughput, and maybe changes a few of the subtle dynamics of the underlying system. And folk can take an even further level of abstraction away from the process, and they can say, well, maybe I can analyze it and find a new way of solving this particular problem. So like a brand new process to apply the cap to the bottle, as it were. Right? And so folk here are not looking at an individual process now, but they're sort of looking at the way in which the whole system works and loads things up and moves along. And then we can think just from analysis what happens next, and that's about tactics. It's about like forecasting stock. It's about making sure the value chain is well aligned to the production chain. It's just making sure that the components of the system are all well mannered and well metered together. And finally, at the most complex part, or the greatest unique value that a person can add, is at a strategy and creator level, making systems again, thinking strategically about these things. Am I going to invest in this machine because it will enable this kind of new technology? Or will I invest in optimization over capacity? Those sort of core questions. So it's a really nice way of sort of looking at the things that go inside a business in an abstract fashion. And it's super important to know this, because the transformation that you need to go through to bring AI to life means that these sort of operations are really important to understand, to identify the correct change point. Then I think the additional component around people. So in this one here, this is the immediate hands and brain that they bring. But this speaks to the sophistication of the person involved, right? So you can have a process, but the process is very complex that a person does, and so you need to have a very sort of sophisticated person that gets onto it. But if we think about the lowest level of sophistication in an abstract operation, these are operators. These are specific experts who have people who have interface-specific expertise. So they know just how to sit on this tractor just right, warm it up on a cold morning such that the tractor can plow the field through the course of the day. It's that like very niche knowledge. It's not born from a theoretical perspective, but it's born from training, from experience. And typically you find a lot of folk in very mature operations who have this sort of deep intrinsic knowledge. Folk can sort of sit on a machine and say, this thing's, the motor is knocking a little bit hard. Then we're going to go and fix it. Then we can think about task experts. and they understand the tool at maybe a more abstract level. So it's not about driving the process or the specific interface, but it's sort of thinking, well, maybe if I set up the CNC machine in the following way, it can give me a specific output. Or it is about like at a bank where you have somebody who's like knowledgeable in specifically granting credit to individuals. And so they're sort of experts. They can understand the instrument of providing credit, or they can provide the sort of CNC machine settings. You don't want to cut too quickly because of too much force on the cutter, for example. Stepping further back, we can look at these problems. We can look at the data that come out of the systems and processes, and we can say to ourselves, well, what does this data tell me, right? And we can generate insights from numerical trends. This is very different, sort of like putting your hand on a machine and feeling how it vibrates, saying, okay, this has got a problem, versus looking at the data from some kind of accelerometer, and it says, okay, well, hang on, we have an emerging vibration issue out of it. And the next interesting component is where folk can act as a function generator and sort of look at these things and say, well, if I connect this data and that data and I run a little bit of a transformation, I can get this output. This output has value to my business. So by making decisions on this complex output, we can be better, right? More efficient, or whatever you want. Then you can hand that decision-making power off into an AI system. So you can sort of say, well, here's this output. What do you think about it? What is the right thing to do? What's the trend analysis I need to look at? And so on and so forth. Here, where people build systems, we can also have system architects, where they sort of understand the concept of a system at an abstract level, what the boundaries around this, the problem space would be, what the inputs are, and so on. And finally, we have the innovators, right? The folk who say, well, no, this is not good enough, but I'm going to make something that is. I'm going to change the world. And so you can look at a specific problem domain and sort of tease this out, and get your own sort of right answer. And in the last dimension that we're going to chat about today is about the business. This talks to maybe more about how the business is positioned in the market. It's, you've got this thing that's producing value. Shareholders are delighted in the value it's producing. But how sustainable is it? How is the market going to change, and therefore how well suited is your business for the future, right? So if you are a commoditized regional player, that means that you are one of many, and that in the region you are in, that you are one of many. So you can kind of think about this in a big city as a bakery. There must be hundreds of bakeries throughout the city, and there's probably no differentiating value proposition between these bakeries, and they're probably just able to serve little areas based on geographic location. So this bakery serves that neighborhood because it's in that neighborhood, which means that the agenda of how you bake bread is set by this collective, right? So everyone's going to be looking for more efficient ways to bake more bread, to distribute it more widely. And so you've kind of got to hang on and stay up to speed with what everyone else is doing. And so you are ripe for disruption if you have no sort of differentiator from the rest of the world. You can still, the next evolution here is where you are a niche specialist and you've got a regional market, but you've got some kind of differentiation. So maybe you produce sourdough bread and nobody else does, which means that you have some corner of the market sort of fenced off that you get to exploit through your specialization. Right? And so if people want sourdough bread, they go to you, but if they want just normal bread, they go to anybody else. But perhaps you are even more unique, where you then make the best sourdough bread in the whole country. And so you have sort of national recognition of your quality. And so you have a differentiation, not just at a regional level, but at a national level. So it's much larger geographic isolation. You don't necessarily have access to international markets, but folk would possibly buy your bread because they want to eat it, and you would ship it overnight to get there. The next sort of level of uniqueness in a business that is important to sort of think about from an AI disruption perspective is, how do you form in a sector? So you sort of like in a vertical, in a sector, as it were, you do a whole bunch of things differently. So maybe you provide a form of sourdough bread that nobody else can, in addition to provide home baking kits. Nobody else does that, for example. And so folk can say, well, in the baking sector, these folk are the absolute winners, absolute unique folk. We can start expanding that. We can start thinking about this globally, kind of same differentiation story. But what this really means is that as you become more unique, there are fewer people who are looking to eat your lunch because they can't, which means that technology changes or technology innovations are far less likely to disrupt you as an individual. They're far more likely to disrupt a commoditized market where there's lots of people who look about the same because the disruptive effect there got lots of people seeking it. But you're the only one who does this small one of a kind thing. And I think this is sort of where I'm headed to with this whole argument, this whole like one of a kind thing. Then you sort of get to be a little bit more protected, maybe a little bit more isolated from the forces of the world, as it were. Right. So, folk, I think mindful that I've only got half an hour and I've got 4 minutes left. What I want to do is actually just show you how you can make this real for yourselves, because it's nice to know about this framework. It's nice to sort of look at yourself from it. But in terms of an actual quick little run through, I'm going to show you how you can use it today. It's 2 seconds. Almost there.
Mike, just to let you know that we can overrun a few minutes if necessary.
Amazing. Thanks for doing that. Great. So, folk, what I'm showing you here is that URL, right? So it's nebula.synthesis.rocks. All you do is you take these specific problem dimensions that I spoke to and you answer them with respect to your individual problem statement, right? This is the thing that matters for you. So, how are you doing these various components? And then you can go and get your archetype. And so from your very specific answers, the system builds out its own relevant strategy just for you, dependent on your answers, and talks to things that you may not necessarily be aware of over the sort of span of several years. So it's a 5-year strategy that takes this evolution, this maturity, the power of the current technology, and builds it out in a way that is relevant to your business. Anton, perhaps while it's busy generating, I could take a question or two if there are any.
Yes, there's one here about what challenges you commonly experience.
Absolutely. What a great question. I think the biggest challenge with technology is the way in which folk think about it and how they drive that adoption. It's not ever so much about the specific technology. It is more about driving that adoption into your business. So maybe to make this a little bit more real, here is the strategic plan that was generated from these set of answers. I have an archetype of an innovative systems architect. And so really it's about understanding how to get to the success criteria. Like what are the steps we would need to take to get there? So I'd have to have a team, and this one has identified that generative AI is the right kind of AI for me. But year one here would be understanding the potential as well as identifying those potential applications within the current business context. Year two is about the development and implementation in one identified area. Year three is expanding that implementation across multiple business areas and optimizing performance. Year four is about efficiency improvement and cost reduction. And year five is the shift of the business as a whole to use that AI technology.
So thanks, Mike. I'm very grateful that you've used language that I can understand. Um, so let's quickly look at one more question. which is yeah, a bit involved. It says here the ultimate goal of lean is transformation, and AI is commonly regarded as disruptive. So, is disruption forced transformation?
A beautiful question, and I think that the um, individual who asked it is really grappling, probably grappling with those issues on the front line. I think the very definition of disruption is some kind of change that is happening outside of your sphere of control or your domain of control. So it's very much something that is happening to you, not being driven by you. But I think disruption speaks to change. Whether or not disruption sticks is very much open to the type of disruption. Right? We all had Tamagotchis many years ago, and that was wildly disruptive to the children's game market. They didn't stick around, right? It was entirely transitory or transient, and yeah, so not something that's particularly impactful in that narrow piece of time. But here it is in our language, in our vernacular today, used as an example, almost 2 decades later. So I think that's super important, right? So like change is going to happen. It can be quick and controlled from within, or it can be pretty large and out of control and coming from without. And I think that is the definition of disruption. So to understand what's coming down the pike, to understand where you sit on this disruption spectrum is really important because it allows you to adopt the correct stance to benefit from it.
Great. So we're just over time. We'll have to leave it there. But thanks, Mike. And thanks to the participants. I would like to encourage you to give Mike's framework a try. Who knows? Maybe one of you will be that innovator that Mike talked about. Thank you, Mike.
Thank you
Bye
for the
then.
opportunity, folk. Appreciate your time. Cheers.